Hi everyone. In this video, we are going to be doing A-Level Maths 9709, paper 42, Mechanics, October, November 2025. This paper is 1 hour 15 minutes long, so try to finish within the time limit. So let's get started. Okay, so for the first question, we're given a diagram which has the displacement time graph for motion of a particle. The particle starts from rest at a point O. So this keyword starts from rest and travels with constant acceleration a meters per second square. So we can see that in the graph here that the gradient of the graph is increasing. So that means the velocity isn't constant because that's what the gradient of a displacement time graph represents, which is the velocity. Okay, and then it also says that it takes 4 seconds to move a distance of x meters. Okay, so x is here. Yeah, it correlates. The particle then returns to O with a constant speed of 40 meters per second. So from here to here, it goes back to O. And the gradient here is constant. And the gradient must be negative 40 since the speed is 40 meters. And as I said earlier, the gradient of a displacement time graph represents the velocity over a period of 2 seconds. So you can see from t equals to 4 to t equals to 6. Okay, so now we have to find the values of x and the value of a. Okay, so to do this, let's start by finding the value of s. Okay, so we know that from here to here, it goes from point O to x, right? So we can use the Suvat formulas. Okay, so we can use this since we know the time and the initial velocity as well as this. We don't know the final speed. Okay. Yeah. So let's use those two. So v equals to u plus at. So x equals to u. So it starts from rest, so u is 0, so it's only at. So a times t. So a is a, and then t is 4, since it takes 4 seconds. So we get x equals to 4a as our first equation. Now we're going to use the second formula, s equals to ut plus half a t squared. So in this case, s is, again, the distance traveled. Wait. Hmm. Oh, wait, sorry. For the first question, this is actually the final speed, v. Okay. Yeah. So yeah, now here s is going to be equals to x, and then u is 0. So we have a t squared. So half a t squared. So t is 4 squared. So 4 is 16 over 2. That's 8a. So this is equation number 2. Okay, what other what formulas can we use? Okay, let's use this one. V squared equals to u squared plus 2as. So we know the final initial speed as well as the acceleration and the distance. Okay. So v squared equals to u squared plus 2as. So u squared is 0, and then 2as. So 2as is x, and v squared is 4a whole thing squared. So that's 16 a squared. So the a's cancel out. Um, Okay. Yeah, I don't think we need any more equations since we get the same value. Oh wait, sorry. Yep, the erase function isn't working. So yeah. All right, so we have our equations for p and x. Now, to find a, we know that the gradient here is -40. And to find the gradient, we need to know the x and y coordinate of this point as well as this point. So for this point, the x coordinate is 4, y coordinate is the displacement x, and for this point, it is 6 and 0. So yeah, let's substitute into the gradient formula. So x minus 0 over 4 minus 6. This would be equals to -40. So now we can find what x is. So x is just going to be 80. Yeah. So yeah, this would be our first answer. Now we are just going to substitute into equation 2. So 8a is equals to 80. And then we get a is equals to 10 meters per second square. Okay, actually, we don't need the unit because it's already included. So yeah, these two are our final answers for this entire question. Let's move on to the next question. Okay, so for this question, we are told that a railway locomotive of mass 240 kg is towing a coach of mass 36,000 kg down a hill incline at an angle of sine inverse 0.04 to the horizontal. So let's start by drawing out the hill. So this is the angle theta, sine inverse 0.04, and this would be the locomotive. Okay, okay, this would be the locomotive, and then behind there is the coach. So the locomotive has weight 240,000 G or 2.4 million newtons. And the coach has 360,000 newtons as its weight. Okay. And we also told that the driving force produced by the locomotive is 450,000 newtons. So we also have the driving force by the locomotive, 450,000 newtons, and their resistances to motion of 120,000 newtons on the locomotive. So on the locomotive only, we have 120,000 resistive force and 15,000 on the coach. So we also have for the coach, which I'm going to draw right here. Okay, and then the coupling between the locomotive and the coach is light, rigid, and parallel to the hill. So we can treat this as a string, okay? And in the string, there's always tension. So from the perspective of the locomotive, the tension would be acting here, and for the coach, it would be acting in the opposite direction. And we have to take these into account when we take either the locomotive or the coach as their own system, as a separate system. Okay? Yeah, so using all this, we need to find the acceleration of the locomotive, which we can rephrase it as the acceleration of the entire system, and the tension in the coupling, or T. Okay, so first let's try to find the acceleration of the locomotive. Okay, so to do that, since we don't know what the tension is, sorry, since we don't know what the tension is, we're just going to take the whole system as a whole. We're not going to separate it. Okay, so we're going to use F equals to MA. So we're going to take the forces acting downhill as positive because it is going downhill. So we'll take the driving force, 450,000 newtons, plus the horizontal component of the weight. Sorry. Yeah, so we'll take the horizontal component of the weight, which if you zoom in here, is basically just 2.4 million sine theta. So this is just going to be 2.4 million sine theta, which is 0.04. Same for the weight here, plus the 360,000 sine theta, which is 0.04. And you subtract the resistive forces acting on both the locomotive and the coach, which is 120,000 minus 15,000. Okay, so this is F. So yeah, type all this into your calculator. You would get 339,000 newtons as the force. And the mass, since we're taking the entire system as a whole, would be the locomotive's mass as well as the coach. So that is going to be 276,000 kg times A. So A, if you divide both sides by 276,000, you would get 113 over 92 meters per second squared. Or you can also run it off to 3SF, which will give you 1.23 meters per second squared. Okay, let's see if I did everything correctly. 240,000. Okay. Okay, so I just realized I might have made a typo here, like when I was typing this whole expression here into the calculator. So this is actually supposed to be 425,400. So A would just be 425,400 divided by 276,000. You would get 709 over 460 meters per second squared. Or to 3SF, that would be 1.54 meters per second squared. Okay, so this is our value of A, the final value, but we'll be using this one for calculating tension. Okay, so to calculate the tension in any question like this where the particles are connected, the only way to calculate tension is to isolate any one of the components. So you either take the locomotive or the coach as its own system. So I will choose the coach for my calculation. You can choose the locomotive if you'd like. Okay, so yeah, again, we'll be using F equals to MA. So we'll take the T as the forward force, and then we will also add the horizontal component of coach's weight, which we calculated just now. And then we'll subtract the resistive force acting on the coach, which is 15,000. And then we'll equate it to mass times acceleration. So mass is 36,000. Acceleration, we found it just now. Okay. All right, now we're ready to find it. So 709 divided by 460 times 36,000. Okay, let's not do it. Okay, so let's find out what this entire expression is. It's minus 600, so we can add 600 to cancel that out. And adding 600, you would get 56,100 newtons to 3SF as your final answer. So yeah, we're done with this entire question. Let's move on to the next question. Recording in progress. Okay, so for this question, we're told car of mass 14,000 kg is traveling on a straight horizontal road, accelerates uniformly from a speed of 15 meters per second to 20 meters per second over a distance of 175 meters. So first we need to find the time taken, aka t, to travel this distance. Okay, so this is the keyword here, accelerates uniformly. And since it accelerates uniformly, to find t, we can use one of the Suvat equations. So we know the initial speed and the final speed as well as the distance. We just want to find the time. So considering those, this would be the most suitable formula. This formula. So let's copy it down. S equals to half plus U plus V T. So S is 175, half U plus V. So U plus V is 15 plus 20 T. Okay, so T will be 175 times 2 divided by 35, which is 10 seconds. So this would be the final answer for the first part. Let's move on to the next part. Recording in progress. Okay, so for this part B, part one, we are given new information that there's a constant resistance force of 800 newtons to the motion of the car. So for the first part, we're supposed to use an energy method throughout. So we need to calculate the changes in KE, GPE, and find the work done against the forces to find the average power of the car's engine. So to find that, we need to know the total work done by the car's engine against during the distance it traveled as the speed increased from 150 meters to 20 meters per second. Okay, so uh, to find that, to find the work done by the car's engine, we need to know the force that the car's engine exerted throughout the entire motion. And then we divide that by the time taken, which we found in the previous part to find the average power. So let's do that. Okay, so to use the energy method, we need to understand what energy is being converted, okay? So we can think of this as the kinetic energy. So the speed increases, so the KE increases, right? And then the work done by the car's engine is converted the work done against the resistive force of 800 newtons. Okay. Yeah, so we can do that. Okay, so change in KE. Let's find that first. So the final KE would be half times the mass, 140,000 times the final speed, 20 squared minus the initial KE. Okay, sorry. Let's think of it as the work done by the car's engine is converted to KE as well as the work done against the resistive force. So this one is called the work done, the work energy principle or conservation of energy. So the change is 122,500 joules. Okay, so the work done by the car's engine, that's going to be force times distance. So distance is 175. The force is F, and we can say this is converted to KE as well as the work done against the resistive force, which is 800 newtons times the distance. Okay, and then now just divide both sides by 175. You get 122,500 divided by 175 plus 800. You will get 1,500 newtons. So this is the force exerted by the car's engine. Okay, now work done by the cars. Okay, so now we're going to find the power, the average power. That's just going to be the energy or the work done exerted by the car's engine divided by the time. So work done is just going to be the force times the distance divided by the time, 10 seconds. So 150 times 175 divided by 10, you'll get 26,250 watts. Or in kilowatts, that's going to be 2.625 kilowatts. Wait, no, sorry, 26.25 kilowatts. Yeah, so this would be our final answer for the first part. Let's move on to the final part.
Recording in progress.
Okay, so for the last part, we need to find the steady speed. So to maintain a steady speed, from Newton's first law, all the forces must be in equilibrium. So and here we're told that there's a resistive force of 800 newtons. So to maintain a steady speed, the force exerted by the engine has to counteract that force. So the engine can exert 800 newtons. So that's when we'll reach the steady speed or constant speed. Yeah, so it tells us to find the steady speed that the car could maintain on the horizontal rope if the engine is working at the power found here. So basically at this power here. So this is very simple, okay? Just have to remember this formula, power equals to force times velocity. Now we'll make our velocity the subject, which is power over force. So power that is 26,250 and force, like I said, that's going to be 800 newtons. It has to directly counteract the resistive force and hence maintain equilibrium. So yeah, just type into a calculator. You would get this as your exact answer. So yeah, this would be our final answer for this part as well as the entire question. Let's move on to the next question.
Recording in progress.
Okay, so for this question, we're told that a particle P of mass 0.1 kg is projected vertically upwards with speed 30 meters from horizontal ground. At the same instant, a particle Q of mass 0.4 kg is projected vertically upwards with speed 10 meters from a height of 15 meters above the ground. P and Q move in the same vertical line. Okay. All right, so first part, we need to find the height above the ground at which P and Q collide. All right, so let's make a little sketch. So this is P. Okay, so P is projected at 30 meters per second vertically upwards. Yeah, I'll put a bracket here with its mass. And Q is projected also vertically upwards in the same vertical line, but from a higher height of 15 meters. So I guess I just put Q here. So Q is 0.4 kg. It goes at 10 meters per second. And the distance between them is 15 meters. Okay, so this is all the information that we have. Okay, so we need to find the height above the ground at which they will collide. So we need to find the first common height that they reach. Okay? Okay, so we're given their initial speeds and the distance. Okay. All right. So when they reach this same height, if you use a bit of common sense, they should obviously reach at the same time. So the S and T should be the same. Yeah. So those are the two undisputed things. Yeah, so the acceleration is both negative g, right? So let's use the Suvat equation. So for S, well, let's do for P first. So it's 30 T plus half AT squared. So plus half negative G, which is negative 10 T squared. That's for P. And then for Q, yeah, oh, and for P, since it has to first cross the 15 meters barrier, you also have to add 15 to here. And then for Q, it's just going to be the height S that it has to conquer. So it's going to be 10T plus half negative G T squared. Okay, so these are our two equations. Now we'll just sub the second equation into the first equation. So 15 plus 10t minus 5t squared equals to 30t minus 5t squared. So you can see we're minus 5t squared on both sides, so we can cancel those out. And now we can minus 10 from both sides to give us 20t equals to 15. And then we will get t equals to 15 over 20, which is just 3 over 4 seconds. And now to find the height above the ground, just sub this value back into equation 1. So we'll sub t equals to 3 over 4 into 1, because they want the height above the ground, not the height traveled by Q. So the height above the ground is the height traveled by P. Okay, so 30 times 3 over 4 minus 5, 3 over 4 squared. So you would get 315 over 16 meters as your final answer. So with that, let's move on to the next question.
Recording in progress.
Okay, so here we're told that when P and Q collide, they coalesce. So coalesce, it's a very important keyword for mechanics. It basically means they combine into one body. So they're no longer P and Q, they're a new body called P plus Q or R. Okay, so for part B, we need to find the speed of the combined particles. So this is the evidence at the instant that it reaches the ground. Okay, so to find that, we are going to work backwards. So to find the speed when it reaches the ground, we need to know the initial speed of the combined particle, which is basically the speed at the instant that they collide together. Okay, so to find that, we need to use our conservation of momentum. So we need to know the speeds immediately before the collision when they are at this height at time t equals to 3/4. Okay. All right, so let's find. So I'll let the initial speed before the collision be u. Okay, so UP is gonna be the initial speed that P is projected at, which is 30 meters. So 30 meters and then plus a t squared. So a is negative 10, and then t is t is 3/4. Yeah. So if you just type into a calculator, you would get 45 over 2 meters per second. Now let's do the same for Q. So Q is 10 minus 10, 3/4. Yeah, you would get 5/2 meters per second. Okay, now let's state the conservation of momentum formula. So the total momentum of P and Q is equals to the momentum of the combined particle immediately after the collision. So MUP plus MP plus UP plus MQ times UQ equals to MP plus NQ times U. So U is the speed of the combined particle immediately after the collision. Okay, so MP is 0.1, UP is 45/2, NQ is 0.4. Yeah, and then UQ is 5/2 plus MP plus MQ, that is 0.5 U. So just multiply everything, divide by 0.5 on both sides. U is equals to 6.5 meters per second. So this is the initial speed of the combined particle. And now with that, we can find the final speed, V. So to find V, we know the height at which it will travel. So the height would be this height here. So since we know the height and want to find the final speed, and we know the initial speed, we're going to use this formula, v squared equals to u squared plus 2as. It's in your MF19 as well. So v squared, 6, 5 squared plus 2. A is g, which is 10, and s, which is 315/16. And if you want to get v directly, just square root everything. Okay, so 6.5 squared plus 2 times 10 over 315 over 16. So you would get 2 squared 109 meters per second. Or to 3SF, you get 20.9 meters per second. So yeah, this would be a final answer for this last part as well as the entire question. Let's move on to the next question.
Recording in progress.
Okay, so for this question, we're told that a block of mass 5 kg is being pulled straight down a line of greater slope of a rough plane. So rough plane means that there's friction acting on the block by a force of magnitude 20 newtons. So yeah, this is the force that they're talking about. The plane is inclined at an angle of 10 degrees to horizontal, and the 20 Newton force acts at an angle of 35 degrees above the line of greater slope of the plane. So yeah, this is what they're talking about. So you can see this is the 35 degrees, and this is the 10 degrees. The coefficient of friction between the block and the plane is 0.4. The speed of the block when it passes a point O is 2 meters per second. Okay, so O is just a generic point. Okay, so we need to find the speed of the block when it has moved 3 meters down the plane from O. Okay, all right. So uh, to do that, we have to know the speed when it's at O. So they already gave that to us. And we also have to know the acceleration that the block is experiencing when it passes through O. And yeah, we're also given the distance. Yeah, so I believe that should be sufficient info. We just need to find the acceleration of the block. Okay, so to do that, let's label all the forces acting on the block. So first is obviously the weight of the block, which is 5G. And since it's a rough plane, there's friction, so it's being pulled down. So the friction would be here. And there's also this, wait, sorry. And then there's also okay, ignore this line. And then there's also the normal contact force, R. And yeah, I believe that's all for now. Okay, so first let's take the vertical forces. Since, it's not going up or down relative to the slope, right? It's not going vertically relative to the slope. We can assume that all the vertical forces are in equilibrium. So let's take the vertical component of all the forces. So I can see that the 20 Newton force has a vertical component in the upward direction, which is just 20 sine 35. And the weight also has vertical component acting downwards. So this angle, if you have done enough mechanics question, you would know it is 10 degrees. So this is just going to be 50 cosine 10 degrees. Yeah, so we can equate R plus 20 sine 35 degrees equals to 50 cosine 10 degrees. Okay, now let's make R the subject. So R is just going to be 50 cosine 10 degrees minus 20 sine 35 degrees. So this is equation 1. And now let's do the horizontal forces. So obviously for the horizontal side relative to the slope, it's accelerating in this direction. So take the horizontal forces to the right first. So that would be the horizontal component of the 20 Newton force, which is 20 cos 35 as well as the weight, which is 50, which is 5g, sine 10. Yeah, so this is 20 cosine 35 plus 50 sine 10 degrees minus f, and that would be equals to MA, which is 5. Sorry, just which is 5 A. Okay, and then F we know is equals to mu R, and mu is 0.4. So F is just 0.R. So we can substitute that in, as well as substitute equation 1. I'll just leave it alone for now. Okay, now let's isolate A. A is going to be 20 cosine 35 degrees plus 50 sine 10 degrees minus 0.4, 50 cosine 10 minus 20 sine 35 degrees over 5. Okay, so let's try simplifying that. So this is the same as 4 cosine 35 degrees. So 20 divided by 5, 50 divided by 5, that's 10 sine 10 degrees minus 0.4 times 50 divided by 5, that is minus 4 cosine 10 degrees. Minus 0.4 times minus 20, that's 8 divided by 5, which is 1.6 plus 1.6 sine 35 degrees. Yeah, so this is the value of A. We'll keep this exact value because we want to find the speed of the block, which we need to know the acceleration. So since the acceleration is constant, we can use this formula, which we used in the previous question. It's also in the MF19, v squared equals to u squared plus 2as. So v going to be square root of u squared. So u squared is 2 squared plus 2a. So a is this whole expression. Fortunately, I don't know how else to simplify it. So bear with me as I copy it down. Times s, which is 3. Okay, so I guess I'll just write the 3 in here. Okay, so 4 cos 35 plus 10 sine 10 minus 4 cosine 10 plus 1.6 sine 35. So this is the acceleration. So 2 squared plus 2 times the acceleration times 3 square rooted. You would get 3.99 meters per second as your final answer to 3SF. So yeah, this will be our final answer for this question. Let's move on to the next question. Bismillah.
Recording in progress.
Okay, so for this question, we are told that a particle starts from rest at a point O, and the acceleration of the particle at time t seconds after leaving O is a meters per second squared, where a is equals to this for t more than or equals to 0. So using this, we need to find the distance, not the displacement, that the particle travels from O until the time at which its acceleration is zero. Okay, so before we find the expression for distance or displacement, let's find this time that they're talking about first. So very simple, just substitute a equals to zero to your acceleration formula. Okay, so you get t plus 1 to the power of negative half equals to half. Okay, and then, okay, just square both sides. You get t plus 1 to the power of negative 1 equals to half squared, which is 1 over 4. Okay, now since you want to remove this negative power, just put the negative power on both sides, and this just, flips the fraction on the right-hand side. So you get t plus 1 equals to 4. And then t would be equals to 3. So this is the time that we're interested in. So we want to find the distance from t equals to 0 to t equals to 3. Yeah, so these are our limits. Okay, so now we're going to find S. So to do that, we need to find V first. And to find V, we have to integrate expression for A. So integrating 2 times t plus 1 to the power of negative half minus 1 dt. So remove the 2 and integrate this thing only. So adding 1 to the power, you just get half as a new power. And you divide by half, which is same as multiplying by 2. So you get 2 times t plus 1 to the power of half divided by the derivative of t plus 1, which is just 1. And then minus integral of 1, that is t plus c. Then you would get 4 times t plus 1 half minus t plus c. Okay, now we will, okay, so it says it starts from rest, so that means v equals to 0 at point O. So v equals to 0 when t equals to 0. Okay, so 4 times 1 minus 0 plus c, c equals to 0. So you get 4 plus c equals to 0. Therefore, you get c equals to negative 4. So therefore, you get v equals to 4 times t to the t plus 1 to the power of half minus t minus 4. But we're not done yet. We need to find s. So to find s, you need to integrate the expression for v. So that's 4 plus t plus 1 half minus t minus 4 dt. Okay, so integrating that, and you leave the 4 alone, integrate this. So half plus 1, that's 3 over 2. So you divide by 3 over 2, you get 2 over 3 times t plus 1 to the power of 3 over 2. Divide by the derivative of t plus 1 minus the integral of t, which is t squared over 2 minus the integral of 4, which is 4t plus 2. Then you would get 8 over 3 t plus 1 to the power of 3 over 2 minus t squared over 2 minus 4t plus c. Okay, okay, so at point O, we know s equals to 0 when t equals to 0. So t equals to 0, you get 8 over 3 times 1 minus 0 square over 2 minus 0. So all 0 plus c equals to 0. And then you would get c is equals to negative 8 over 3. Then you would get s equals to 8 over 3 times t plus 1 to the power of 3 over 2 minus t squared over 2 minus 4t minus 8 over 3. So this is our expression for s. Okay, so now what we can do is to okay, so now we're going to kind of sketch a diagram. So this is the displacement at t equals to 0. Now let's do for t equals to 1. So t equals to 1, just substitute the whole expression into your calculator. Minus 8 over 3, you get 0.38. So this is t equals to 1, t equals to 2. You would get 1.19. So this t equals to 2, and finally t equals to 3. So the reason we're doing this is to see whether like the particle turns back or whatnot. Okay, so this one you get 2.17. So it still continues to go to the front. So yeah, this is the trajectory from t equals 0 all the way to t equals 3. So to find the distance, we can just substitute the t equals 3 straight into the formula. Okay, so just write down the whole equation. Minus 4 times 3 minus 8 over 3. You would get 13 over 6 meters. That's our final answer. So yeah, with that, let's move on to the final question.
Recording in progress.
Okay, so for this question, we're given 4 coplanar forces of these magnitudes. So you can see it's all in here. And the angle point-beam directions from 7.1 force x in the vertical plane. Resultant of these forces have magnitude Sn. So this is the resultant force Sn, and x at an angle alpha below the horizontal, as shown figure 7.2. So first part, we need to find the value of S and the value of alpha. So basically, we need to find the magnitude of the resultant force as well as the angle alpha. Okay, so to find any resultant force, you're going to work this step by step. We find the vertical resultant force first. So let's find all the vertical forces. So we have the upward vertical force for the 30 newtons acting at 30 degrees. This is going to be 30 sine 30 degrees, as well as 20 newtons. This is going to be 20 sine 20 degrees. And then we also have for 15 newtons acting downwards, that's 15 sine 45, as well as 25. So thank goodness they already gave us the direction. So the vertical component of this is downwards. So therefore, we're going to subtract the downward force first. So 25 Newton plus 15 sine 45 minus 30 sine 30 degrees. That's the upward force, minus the second one, which is 20 sine 20 degrees. Okay, so now just type that into a calculator. Okay, so this part we get 20 plus 15 square root 2 over 2. And then this one we can just leave it alone. Yeah, so this is our vertical resultant force. Now we're going to do our horizontal resultant force. So horizontal resultant force is here. It acts towards the right. So yeah, let's take the right result, horizontal forces first. So we have 30 cosine 30 degrees and 15 cosine 45 degrees. And for the one to the left, we only have 20 cosine 20 degrees. So just add those up. 30 cosine 30 degrees plus 15 cosine 45 degrees minus 20 cosine 20 degrees. Yeah. So again, we'll do this one first because those are pretty perfect. Plus 15 cos 45. We would get 15 square root 3 plus 15 over 2 square root 2 minus 20 cosine 20 degrees. So this is the horizontal resultant force. And now we can use this to find S. So S, use your Pythagoras theorem. So if you move this over to here, you can see that there's a mini right angle triangle. So you can use your Pythagoras to find out. So 20 plus 15 square root 2 over 2 minus sine 20 degrees squared plus 15 square root 2 plus 15 over 2 square root 2 minus 20 cosine 20 degrees. So as you would get 27 to 3SF. And to find the angle alpha, you just take the tangent inverse. So using the right angle triangle analogy, take tangent inverse of this, of the vertical resultant force over the horizontal resultant force. So that's going to be 20 plus 15 square root 2 over 2 minus sine 20 degrees over 15 square root 3 plus 15 over 2 square root 2 minus 20 cosine 20 degrees. So tangent inverse 20 plus 15 square root 2 over 2 minus sine 20 over 15 square root 3 plus 15 over 2 square root 2 minus 20 cosine 20 degrees. Okay, then you'll get 48.7. So okay, the degrees is already given. So yeah, the one decimal place. So yeah, these would be our final answers for the first part. Let's move on to the last part. Okay, so before I go on to the next part, I realized I made a silly mistake in here. So I forgot to copy down the 20 here and here. So this one is supposed to be 22.5 to 3SF. And this one is supposed to be, hold on, give me a moment, over 30 plus 30 plus 15 cos 45 is 20 cosine 20. Yeah, and this is 37.7 to 1 dp. So yeah, these are final answers. Let's move on to the next part. Okay, so now we're told that a small ring of mass of 0.6 kg is threaded on a rough, straight horizontal wire. The four forces shown in figure 7.1 act on the ring and are in the same vertical plane as the wire. The ring starts from rest and takes 3 seconds to travel a distance of 2 meters along the wire. So for this, we need to find the coefficient of friction between the ring and the wire. Okay, so from here, we can take the acceleration that's acting, right? So, so we have U and S and T. So the only one that's left is the final speed or the acceleration, which we can use uh, to find the acceleration. Okay. Okay. Um, okay, so to find the acceleration, okay, the straight horizontal straight wire. Okay, so mm, the four forces act on the ring and are in the same vertical plane. All right, so I guess we can assume that the friction, hmm, okay, there's no horizontal force. So I believe okay, let's just draw a diagram. So S, we already found is 22.5. It's at an angle alpha, and friction would be somewhere here. Mm, yeah, there's also no, okay. And then there's also the weight, 0.6 G and R. Okay. All right. So, yep, again, we can assume that the vertical forces are in equilibrium. So we're going to equate R equals to the vertical component of this, which we know is this exact value. So 20 plus 15 square root 2 over 2 minus 20 sine 20 degrees. Uh, plus 0.6 g, which is just 6. Yeah, so this can be equation 1. Okay. All right, and then for takes 3 seconds to travel. And then for this, so it starts from rest and takes 3 seconds to travel distance of 2 meters. But we don't know the acceleration. So 2 meters. So S goes to half UV T. So, okay. Well, we can use S equals to UT plus half AT squared. So S is, and then U is 0, so half A3 squared. Then A, you would get 2 times 2 divided by 3 squared, which is 4 over. Okay. Now we can take the horizontal forces. So this is the direction of motion. So that's going to be the horizontal component of this, which you found out in the previous part is a 15 square root 3 plus 15 over 2 square root 2 minus 20 cosine 20 degrees minus f. So f, we can substitute mu r. That's equals to ma. So m is 0.6 and a is 4 over 9. Okay. I guess we can. Sorry. Okay, I guess we can simplify this, round it off to 5 dp because it's too long. This is 17.794 minus mu, and then r is, oh, okay, so r is 20 plus 15 square root 2 over 2 minus 20 sine 20 degrees plus 6 equals to 0.6 times 4 over 9, which is 4 over 15. Okay, now we're just gonna use mu. All right, so this is gonna be 17.794 minus 4 over 15 divided by this whole thing. So divided by 20 plus 15 square root 2 over 2 plus 6 minus 20 sine 20 degrees. Okay. Divided by you would get 0.887 to 3SF as your final answer. And yeah, with that, we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future videos regarding A-level maths and further maths. And if you found this video helpful, please make sure to like and subscribe to this channel. If you have any feedback or any like comments in general, leave them down in the comments, and yeah, see you again next time. All right, thank you.